We are back after a winter break, and today we have a pleasure of hosting Andrea Prat from Colombia. Welcome. And the title of the presentation is Competing Ideologies, Fit, Simplicity, and Fear. And this is joint work with José Luis Montiel Olea. So our format hasn't changed. So it's still 1 hour presentations, including questions. Typically, we reserve about 10 minutes towards the end for questions, but questions can be asked throughout the seminar. If you have any clarifying questions, then please unmute yourself and ask. We can manage that as we go. The talk is recorded. And before we give floor to Andrea, let me just remind you, this is a series of seminars. So this spring, we have 5 seminars prepared for you. They are on Mondays, not exactly every other Monday, but close. And the next seminar is on the 20th of April, so after Easter, by Nina Popkova from Rice. And the title is Why Anecdotes? Okay, Andrea, you have 1 hour.
Great. Thank you so much for inviting me. It's a pleasure to be here, and it's a pleasure to present this work. It's a joint work with Pepe Montiel at Cornell. So let me have a brief introduction, and then maybe I'll stop for general questions. What I want to talk today about is electoral models. And your standard electoral model says voters with a certain utility function. That's a utility that depends on policy P and a state of the world X. And there are many, many versions of that. Some of them have full information, meaning that workers know X and candidates compete on P. Some of them don't have complete information, so voters are not quite sure what the state of the world is. And you have various versions of that. You have simultaneous versions, you have retrospective voting, you have dynamic versions. But an implicit model assumption in pretty much all of this is that voters may lack information about the state of the world, but they understand how the state of the world is generated. They have a model of reality, and that model is fully formed at the beginning of the election. This is an assumption that's more and more discussed in economics. Do we really know as agents how the world works? Do we have a stable model of that, or do we adjust it over time? And I credit Schiller with bringing this question into economics after the financial crisis, and there is an increasing literature, both empirics and theory. And I will tell you exactly how our paper relates to the literature in a second, but let me first try to tell you what we do in this paper. So in this paper, we look at elections, and we kind of make the converse of the standard assumption. So the standard assumption is that voters know the model, but they may lack information. We're going to assume that information is publicly available, is there, it's verifiable. However, voters are not quite sure how to interpret all this stuff. And candidates compete not in providing information, but in providing interpretations for that information. And the question that we ask is what interpretations will emerge. And so we're going to call these interpretations, these are going to be statistical models, we're going to call them ideologies and we're following the literature here. And so the question is what ideologies will arise in equilibrium. And so in a nutshell, and of course then I will be much more precise, the game is as follows. You have this pile of data available there, statistics, impression, anything you want. And there are 2 candidates. These candidates are just trying to be elected, and they announce their ideology. The ideology is nothing more and nothing less than a statistical model of the process that generated the data. And this is, by the way, I realize most people in the audience are empiricists. There is a literature here that's trying to measure this, what these models are. So I think it's an exciting field for both theory and empirical work, and I think it's there's a lot of joint work. So I think it's an exciting thing. Now, these two candidates announced the ideology. And ideology does two things. One thing is that ideology helps to interpret what's going on in the world. The other one is that ideology binds the candidate to behaving in a certain way if they're elected. I am a socialist. I give you a socialist ideology. This will help you interpret what's going on. And if you elect me, I will make decisions according to my socialist ideology. Now, here we're going to make a stark assumption. So the goal of this paper is not realism, but is to kind of do the converse of what's done normally. We're going to assume that the voter was born today and has no prior about the process. So the voter will take the two ideologies announced by the candidates, and that will form the voter's prior. The voter will give 50% probability to each ideology before seeing the data. Then he will put the data on top of these ideologies and will make all kinds of inferences. So from that point on, we will deal with a regular Bayesian decision maker. The voter will be a regular decision maker and will maximize expected utility after that point. And so the voter will choose the candidate that provides a higher expected payoff given the two ideologies announced. Preview of the results. There's going to be a main theorem here, and the main theorem characterizes which ideology wins given the data that is available to observe. And the ideology that wins is the one that maximizes the product of three terms. These are going to be mathematical terms, but they have an interpretation. The first term, we call it fit. Don't get stuck on names. You will see the mathematical definition, and that's what matters. And fit is simply the maximum likelihood residual. So an ideology is more likely to be a winning ideology if it fits the data well. Second one is simplicity, and that too should not be very surprising. It is how complex the statistical model is in the sense of being able to explain lots of other data that's not observed. This is a minus because a model that can explain everything does not have a lot of predictive power. And the third one is something I believe sort of new, and it's a fear factor. We call it a fear factor because it's the ability of an ideology to evoke events that if the ideology is correct, but the voter chooses another ideology, will create very negative payoff consequences. So it's the evaluation of another ideology with our eyes. It will become clear mathematically, and I will also have an example before I do the theorem. So what literature do we relate to? The closest work, it's Martin and Callender. This is a political science theory paper that defines ideologies the way we define it as statistical models that are both a way to explain the world and commitment on the part of candidates. What we do is that in their case, it's just a linear ideology, while our ideologies will live in a completely abstract space, and this will allow us to, in their case, only fit matters, while in our case, both complexity and fear will play a role. There are other papers in political economy that look at narratives, if you want, that are supplied by candidates. They're different from us in many ways. So that's the closest paper. I am happy to discuss them, but they're different. More in general, we relate to a literature initiated by Schwartzstein and Sundaram, persuasion through models, which is the idea of staying within the Bayesian paradigm, but assume that there's someone else there that's trying to affect your model. I think this is a good place to stop and see if there are general questions about what I'm trying to do. Fantastic.
No general questions. I'll just note that the first paper on the slide is it also was presented in our Polycon UK webinars a couple of years ago, so you can watch it online.
Fantastic. So let me then dive into the notation, which is not that complicated, I hope. There are two candidates, A and B, and one voter. The payoff of the voter is, and I always wonder, can people see my cursor if I move it? Fantastic. The payoff of the voter is a certain utility that depends on an action and on a state, Zn plus 1. Why n plus 1? You will see it in a second. So n plus 1 is a future state of the world, and A is some policy, and this is what generates payoff. You have to choose the policy that's right for the state. The winning candidate will be in charge of choosing policy. So what data is available? As I mentioned, when the world starts, there is this pile of data on the table, and that's the n, and it's n realizations of that state Z. I want you to think of the state Z as a very, very large and complicated random vector. I want you to think of that as everything you can possibly observe. Economic variable, any kind of statistics, the weather, the position of the stars, anything you want is in this large vector Z. The only thing the voter knows is that the future state of the world, Zn plus 1, will be generated by the same process that generated the data so far. The voter has no prior distribution of the data generating process, and this prior will be formed by the ideologies that are announced by the candidates. So what are these ideologies? An ideology is simply a statistical model of the process that generated Z. So this has two components. We are now in Bayesian statistics. There's a model M that maps parameters into probability distributions. And so there's this parameter theta, the probability distribution of Z is conditional on this parameter theta, and the parameter theta has a prior distribution, some prior distribution, and typically you think of a conjugate or diffuse distribution. So what's an ideology? An ideology is a pair of a model and a distribution of parameters, and it's a model, and there is a finite ideology set H. So what are we trying to capture with these ideologies? We're trying to capture systems of thinking. So socialism could be a system of thinking. It tells you which variables to look at and what relationships you have between these variables. It doesn't tell you the exact parameters. Maybe you can estimate these parameters with the data. Same for neoliberalism, populism, and so in this world, each candidate, there's a given set there, and each candidate chooses which ideology they use. And so the voter now has the two candidates have announced two ideologies, two statistical models, which we call HA and HB. The voter knows nothing, so she assigns prior probability 50% to each ideology being correct. And her prior now becomes a mixture of the two ideologies. Let us pause for a second. This is just a very standard prior. So now we have a voter that has a standard prior distribution. This voter, the prior was formed in a funny way, right? However, from this moment on, the prior is standard, and this voter is going to be a standard Bayesian decision maker. We don't make this assumption because we think that people are Bayesian decision makers. We make these assumptions because we want to just change one thing in the world, is the origin of priors, and we want to see what that gets us. So the voter is now Bayesian, and she takes all that pile of data and she puts it on top of his prior, and she gets a posterior. She will get, notice that the posterior does two things. It within each ideology, it helps to fine-tune the parameters. So you will get a posterior distribution of the parameters in each ideology, and at the same time, it may change the probability that the voter assigns to the two ideologies. It was 50% in the beginning, but now after seeing the data, the voter may conclude that one ideology is more likely than the other. In general, that will happen. So now the voter has this prior, this well-formed posterior, and she knows how candidates are going to behave if they get elected. So each candidate will make decisions according to the model that she proposed. And so now the voter can evaluate what will happen for each candidate and can compute the policy distribution for each candidate, can compute the expected payoff under the two announced ideologies, and she will simply choose the candidate that offers a higher expected payoff. Dice are broken randomly as usual. So policy making, as discussed, happens as follows. If one of the two candidates will be elected, that candidate will maximize the voter's expected utility under the ideology that was announced. You elected me. I'm a socialist. I bring in my socialist statistical machinery and will make decisions according to the socialist statistical machinery. There's something here you can do sometimes. For the examples, is very useful. You can assume that Z contains some covariates, and these covariates are observed before policy is chosen. So in the example I will give you, that happens because it's a standard example. So the timeline is as follows. Everybody observes the data. Candidate A announces an ideology HA. Candidate B announces an ideology HB. The voter picks one of the two candidates. The candidate that's elected uses his model and the data to choose the policy. Outcome Zn plus 1 is realized, and voter gets the utility.
Andrea, can I ask a couple of questions here? So the first one is, are these candidates strategic, and do they have access to the same H set? Because if there seems to be a lot of homogeneity between the two candidates, so my intuition would tell me that basically you would get something like a median voters outcome. They would choose the same ideology. There is at least an equilibrium in which they would choose exactly the same ideology because there's no heterogeneity in between them. Not that I've seen at the moment. The other question is you're going to have to put some structure on H, I guess. One of the things that's interesting here is that you have two levels. You have the parameters within the model, and then you have the model. So I'm kind of curious if you could give us a hint as to why you don't just have the parameters. Why do you also need the different models and so on?
So, two very good questions, and I will address them later. The first one is that in general, in equilibrium, they will choose the same ideology. I will be more precise. And so what's interesting is deviations. However, it's going to be quite different from a median voter theorem, and you will see it in a second. The second point is this. So on the ideology set, my view here is that in the real world, candidates face a small ideology set. Today in America, if you run as a candidate for an election, you can be a socialist, you can be MAGA, you can be sort of mainstream Democrat. These are the ideologies, and within that set, there is a lot of parameters that can be fit. So that's sort of the main idea. Now we're gonna see how the complexity of an ideology can be a plus or a minus. This is gonna be something that the theory does. But you will see a lot of math around this stuff in a second. So what kind of questions can you ask here? The first question is, given some data and two ideologies, which one will the voter elect? The second question, and this relates to your point, is given some data and a set of possible ideologies, which ideologies will the candidates choose in equilibrium? And the candidates are strategic, they just want to be elected. And the third question is, which ideologies will tend to prevail in equilibrium in this as a function of data and preferences? So there are a lot of modeling choices here, and they're made mostly because not for realism, but because I want to make a clean theoretical point. So candidates are office seeking. You can imagine, and they have commitment. This is a standard assumption in most models. You can relax that. We can discuss it. The 50% prior assumption can be relaxed. You can assume that one candidate is inherently more credible. You can assume that some ideologies are inherently more credible, and our theorem goes on as stated pretty much. Now here we assume that voters select ideology on the basis of expected payoff. You can assume other behavioral assumptions, and we can relate it to that. I can try to tell you what happens if there are more than two candidates. And here, everything is based on the Bayesian approach. Again, it's a methodological choice. So let me give an example of one of these setups. So here you have a state of the world, that Z. It's a long state of the world, and it can be divided into two. One scalar outcome, Y, and a vector of covariates, Z. And the assumption is that the voter's payoff only depends on this outcome. The decision will be as follows. The policymaker will observe all these covariates and will try to use them to predict the outcome y n plus 1. And so here, what's the data? The data is n realizations of the covariates and the outcomes. This is a super standard problem in econometrics, right? Now we can assume that all these models, we can assume that what are the ideologies? The ideologies are all the possible linear models here. And so what's the difference between an ideology and another one? It's the subset of covariates that you include in your model. So for instance, my model may include only immigration. I don't look at other things. I don't look at public investment, for instance. That's an ideology. So what the ideology is doing here is it's telling you what variables you should look at. And as we will see, I will then develop this model later on. What the optimal model is is not obvious. So it's not obvious that you have to include all of them. In fact, in general, you should not. And so we will see why this is interesting. So let me stop and see if there are questions about the model itself. Then I'm going to talk about the equilibrium here. I'm first going to discuss it.
Sorry, I have a question.
Yeah.
Do you allow the ideologies to differ in the parameter estimations? I mean, they use the same set of variables, but one parameter is positive, and in the other the ideology the same parameter is negative, or something like that.
You could. So ideologies can be anything you want. Now, what you're asking is, so the theorem I'm going to give holds for any finite set of ideologies. The question is what are ideologies in reality? My sense is that ideologies are not something of the form. The parameter has a distribution centered around 0.17 with this particular shape. This is not an ideology that you can say to voters. An ideology is a broad system. So in practice, I think that ideologies have diffuse parameter distributions. But again, the formal result will hold with that, and we can discuss what happens when you have like lots of these fine-tuning ideologies. I don't think it's realistic, but we can discuss it. So if there are no more questions, let me discuss so we're going to look at equilibrium here, and I'm first going to do it in a toy example. Then I'm going to give you the main theorem, and then we will have a bunch of other results on existence, on fear, and on complexity. So the toy example is as follows. There are three possible outcomes: -1, 1, and 10. Okay, so there's like two moderate outcomes, -1 and 1, and 10 that's way out there. And there are two covariates, green and red. The data that's on the table in the beginning is 6 observations of the underlying process. And these observations, you observe Y, you observe X. And when you look at these 6 observations, what do you see? There are sort of three patterns. First, the extreme observation 10 has never happened in the past. Second, the other two observations, -1 and 1, have happened 3 times each. Third, there seems to be a correlation between the covariate and the observation. In particular, green seems to be positively correlated with 1, and red seems to be positively correlated with -1. Now, what's the rest of the payoff? There's a policy that's a point on the real line, and the voter's payoff is the cubic, not quadratic. I will tell you in a second why. Is the cubic distance between the policy and Y7. Y7 is the future state of the world. The election is happening now at the end of period 6, and the candidate that's elected will be tasked with choosing Y7. In this world, there are 3 ideologies. So candidates will pick one of these 3. Each candidate can pick one of these 3 ideologies. There is a simple ideology. The simple ideology says this is a very, very simple world, and there are 2 moderate outcomes, -1 and 1. They have equal probability, and the extreme outcome has 0 probability, and that is the world we live in. Nothing more, nothing less. There's a complex ideology that tells you that these probabilities may depend on covariates, and they depend on covariance according to 2 parameters, theta g and theta r. And these parameters are independently and uniformly distributed on 0, 1. The extreme outcome is still impossible. And then there's an alarmist ideology. The alarmist ideology says it's the same as the simple ideology, except that it assigns a probability 2% to the extreme outcome that's never been observed, and that reduces the probabilities on the two other outcomes to 49%. So if this is the ideology set, that's the data that's been observed. What ideologies will candidates announce? And the answer is as follows. Sorry, first of all, notice that if you were to rank these ideologies by fit, it's very simple. The complex ideology beats the simple ideology, and the simple ideology beats the alarmist ideology. Why? Because the complex ideology, if you fiddle with the parameters, you're gonna get a better likelihood than the simple ideology. And the simple ideology has a better likelihood than the alarmist ideology, because the alarmist ideology wastes some probability on something that's never happened. So if you were to choose by fit, you would go for the complex ideology, then simple, then alarmist. But now, if we do it in our way, so we use expected payoff, which ideology will win? And let me first run a match between complex and simple, complex ideology and simple ideology. Suppose that candidate A announces the complex ideology, B announces the simple ideology. Which of the two candidates will the voter elect? The voter assigns 50% to each candidate being right. What's the optimal policy under simple? -1, 1. So you're going to just choose 0 all the time. So X7 is going to be 0. What's the optimal policy under complex? It takes a little while to compute all these things, but it's a number that's close to 0.1, negative if the covariate is red, positive if the covariate is green. Now the voter has a posterior and can look at which of these two policies gives him the higher expected payoff. You can do it by brute force, and the answer is that the expected payoff is higher under simple. Why? What's intuition? The intuition here is that the correlation between the covariate and the outcome exists, but it's pretty weak. And so the complex policy, this is a Bayesian word, so overfitting is not exactly right, but the intuition is that the complex policy is kind of overfitting. And in a Bayesian world, that you will see because the probability that the voter assigns to the complex policy being correct after observing the data is actually below 50%. So from the perspective of the voter, electing someone with a complex policy just will add some noise that's probably not useful. And so simple is better. Now, simple against alarmist, which one will win? So if, again, the voters assign 50% to each ideology, the optimal policy under simple is always 0. The optimal policy under alarmist is slightly positive. Why? Because there's the two moderate outcome, -1 and 1, but the alarmist now has a small probability that 10 is actually what happens. And so the alarmist goes a little bit toward 10, provides the voter with some insurance against an outcome that is unlikely, but if it's likely, it's very catastrophic. Now, the voter realizes that the alarmist ideology is less likely than the simple one. So when you look at it's 50-50 in the beginning. Now the voter looks at the data and sees that the catastrophic outcome has never occurred. And so the voter decreases the probability that the alarmist ideology is correct. Still, that insurance is valuable. And so the voter chooses the alarmist ideology. This is where the cubic distance matters. If it had been a quadratic or something else, it would not have worked. And I will have a proposition later on. So this example, you actually need to complete this example by showing that the alarmist ideology bits complex. I'll spare you. But then you have the equilibrium. So the equilibrium is that simple bits complex, alarmist bits simple. Since there's a unique equilibrium, both candidates announce the alarmist ideology. A deviation from that is punished by the candidate not getting elected.
Andrea, just for clarification, simple bits complex is independent of the utility function curvature that you assume?
I don't think so, but I'm not sure.
Okay. Because I would have thought pure linear would not have worked, but maybe not. I don't know. I need to think about it.
I need to think about it too. I don't know.
Because then you're going to assume cubic and above or something like that.
Yeah.
Okay. All right.
Very good. So,
sorry, I have a small question. So is it possible to get non-transitivity? Because, the prior has quite an effect on what beats what.
Yeah. So I will get into this. You can get non-transitivity. Mm-hmm. If you get non-transitivity, that means that you don't have an equilibrium in pure strategy. And that means that, you have an equilibrium in mixed strategy. I will give examples down the line.
Thank you. That makes sense. Thank you.
And I will give a sufficient condition for the existence of pure strategies. Okay, so a couple more definitions. And then I will probably get to the theorem and not much else. So these definitions are, give me some data, so n realizations of the state Z, and then ideology. Then I can define the likelihood of the observed data within the ideology. This is the standard definition, is the probability of observing the data within the ideology, and I can define it for every possible parameter value within the ideology. When I maximize, I get the maximum likelihood, very standard statistical object, the maximum likelihood of the data within an ideology. There is another object that's the ex ante accuracy of ideology, and that is the ratio between, on the numerator, you see the average likelihood of the ideology for all the possible parameter values. And on the denominator, you find the maximized likelihood. So this is a number between 0 and 1. When it's 1, it means that the ideology is very simple. It just predicts one thing. When it's 0, it means that this ideology can predict lots of things. And I will be more specific in a second.
Can I have a clarifying question? So,
please,
what is the data generation process here? Is it true or is it under ideologies, or what is this probability?
Thank you. There is no truth. So in this in everything I showed so far, there must be a true data generating process, but it has no effect. It does not play any part into the theorem, because the candidates observe the data before choosing the ideology, and all they want is to be elected. They don't care about making the right choice. So in this extreme world, the truth doesn't play a role.
Can I also ask a very small clarification question? Because in the example you had, that the Zs were X's and Y's.
Yeah.
But then in order to predict yn plus 1, which is the thing that you really cared about, you also knew the xn plus 1s.
Yeah.
Because you needed that for the complex strategy. Otherwise, it would have been identical to the simple. So you have to assume that they actually condition.
Yeah.
So I'm kind of unclear exactly. The Z is a bit complicated because there's a subset of which it always includes, I guess, the outcome of interest or the outcomes of interest, and then it includes covariates. So what's the exact assumption about the data that you are going to know? Is it everything up to n, or everything up to n plus 1 for the covariates, but none of the outcome variables, or something else? Yeah. Because here you needed the covariates to come up with example. Maybe I'm just nitpicking, but
no. This is I've been a bit hand waving here. So you and it's easy to illustrate in the toy example. So in the toy example, the data contains each observation is a pair. You have the outcome y and the covariate x, and you observe 6 of these pairs when the election is run. Then what you know is that there will be a covariate will be generated and observed after you've elected the candidate. A covariate will be generated, will be observed by at this point the policymaker, and the policymaker will make a decision on the basis of that without observing the y yet.
So there is kind of yes, the timeline is a little bit more complex. Okay, yeah. Fine.
Okay. A couple more definitions, and I promise that's it. What's the expected utility of an action within ideology H? So now, for any posterior distribution that for any ideology that the voter may have, H, if you combine it with the data, you get a posterior distribution, and you can evaluate the utility of the decision. Sorry, let me be exactly. And you can evaluate the utility, the expected utility given a certain policy decision A. So now you can compute the optimal policy given the data and given a particular ideology. That is the object that the candidate will choose if you elect him. So candidate A will choose will have ideology HA and will choose policy according to this rule. Plus, if you have covariates, they will also be conditioned on the covariate. So now the voter can compute the expected utility of selecting candidate I as follows. It depends on the ideology announced by A, the ideology announced by D, and the data, and you can now compute the utility, the expected utility of the policy chosen by candidate I according to HI, and you evaluate that according to the posterior that's given to you by the two ideologies and the data. With this in mind, you have the main theorem, and the main theorem says that given certain data D, a particular ideology H star is supported in equilibrium if and only if for any other ideology in the ideology set H, this inequality is satisfied. Let me comment on this inequality. And so this is, I think, probably the last thing I will do in the talk. Then I'll skip to the rest, but I think this is the important part. So to provide intuition on this, let me give you a corollary, which one of you had already sort of intuited. And the corollary says that if a particular ideology H star is supported in equilibrium, then there exists a symmetric equilibrium where both candidates announce ideology H star. There can be asymmetric equilibria, but they're really not very generic. So just think of an equilibrium as a situation where both candidates pick the same ideology, and we're now looking at deviations from that equilibrium. And so the necessary and sufficient condition is that these deviations are not profitable. So, and to evaluate this, you can provide a score to an ideology. And this is where the intuition for the theorem will come. And this score for the ideology is the product of three factors. Let's go over these three factors one by one. And an ideology is an equilibrium ideology if this product beats the products of all the other possible ideologies. So the product here is these three factors. The first factor, and we give them names. Don't get stuck on names, it's just mnemonics. So the first factor is fit, and fit is lambda, and lambda is the maximum likelihood of observing the realized data within the ideology. Very, very standard object in statistics, and it's become also a standard object in this literature. This is the explanatory power of the ideology. My socialist ideology is powerful because it explains very well the data that you've observed so far. What you've observed so far has a high probability within the ideology, so that's A plus. Now, is this the only criterion? No, in general, no. And so we can provide sufficient conditions under which this is the only criterion, and they're very restrictive. Basically, you need that ideologies don't have parameters. So they're very simple ideologies without parameters, and you need quadratic payoffs. Otherwise, the other two criteria kick in. And the second criterion is simplicity. So what's simplicity? Simplicity is the ex ante accuracy of the ideology, which is this ratio between the ex ante likelihood and the maximized likelihood. This is perhaps less familiar, but it's a complexity penalty that's imposed in Bayesian models indirectly, and it has two extremes. There could be an ideology with no degrees of freedom, so an ideology with no parameters. I really take a strong stand on what you're gonna observe, and there could be instead an ideology on the other extreme, a theory of everything. What's a theory of everything? Is an ideology that has a parameter value for every possible realization, and that's an ideology where ex post I always fit the data fantastically. But if you're not naive, you will realize that, and you will realize that my fit doesn't have much predictive value. And so you will punish that. And so this is the second component. The third component is what I call fear. And fear is qualitatively different because it builds on the utility function. So let's deconstruct what fear is. Fear is the expected value of the utility difference between my ideology and your ideology. My ideology is H star, your ideology is H. If my ideology is correct, and hence your ideology is wrong. And that is the fear factor because it's saying what is likely to happen to you, voter, if you vote for the other candidate rather than me. An ideology has a comparative advantage if it can evoke these bad consequences for the other ideology. And the best connection, and I have results that then they dig into this deeper, but I think the best connection which was suggested to me by a past seminar participant is Pascal's wager. Blaise Pascal, the 17th century French philosopher, said, so I don't know if God exists, but let's kind of be rational about it. If God exists, if God doesn't exist, then my optimal policy is to lead a life of where I have fun and I do lots of things that are not what God wants. And I will have fun in this life, right? Now, if God happens to exist, then I should lead a life that follows God's religious ideas, and that has a cost for me in this life. However, there is one thing where the two ideologies are asymmetric, and the asymmetry comes from the fact that the God ideology creates a state of the world called the afterlife, and in that state of the world, you get minus infinity if you have not led a religious life. So Pascal's story is I should bet, no matter how small the probability is that I give to God existing, I should actually behave as if God existed because of this minus infinity payoff in that case. So in our language, the God ideology is wonderful on the fear component because it has a very, very large number on the fear component that the non-God ideology does not have. So I'm gonna skip on the proof, although it's kind of nice, and I'm gonna.
Can I just before
please.
you go, just to clarify again on what you do. So this thing here is actually the score is a function of H star and H, right?
Yeah.
So it's relative to H, essentially. It's H star relative to H. So when we're talking about the best strategy, what's the criterion here? Because it's
you
probably
have to beat
not.
All of
I'm
them.
gonna.
You have to beat all of them. So the theorem
you have to be all of
that...
them. It's not like so it's not going to be this one does better on average than this other one, therefore it's better. But sometimes it loses. No, that's not.
No. So you have to, in order for this to be supported in equilibrium, you have to beat all the other ones. Otherwise, you get into what I was about to mention, which is an existence problem. You get the cycles that I think Javier was hinting at before. And so you can have situations, and I have an example in the paper, where ideology 1 beats ideology 2, ideology 2 beats ideology 3, ideology 3 beats ideology 1. Now, they look like Condorcet cycles, but they're completely different because Condorcet happens when you have more than one voter. Here you have only one voter. And this is simply that the one ideology, it's all due to the fear factor. And one ideology has a strong fear factor against ideology 2. Ideology 2 has a great fear factor against ideology 3, and vice versa. In that case, you don't have a pure strategy equilibrium, you have a mixed strategy equilibrium. It's okay. The fear, let me say something briefly about fear. Here we show, we have a result that digs into this idea that of why alarmist ideologies win. And we have a proposition, a very simple case where you've observed the same outcome YZ n times and nothing else. And there are two ideologies. There's a moderate ideology that assigns probability 1 to the observed outcome, and there's an alarmist ideology that assigns probability 1 minus p to the observed outcome, and a small probability to some distant catastrophic outcome. And you can show that if the utility of the going into a space of polynomial utility function, if the risk aversion parameter is sufficiently high, then the alarmist ideology wins, and in equilibrium, the alarmist ideology is always announced. So what's an example of this? I think a nice example of this is immigration. If you think about the United States, you have evidence, you have, I think, over 100 years of evidence that immigration is a positive thing in general. Sometimes it's neutral, sometimes it's positive, but it's never been catastrophically bad for the US. Yet you can imagine, it's a very realistic case, someone becoming president running on an ideology that says immigration could be catastrophic. It could ruin our country. And so what does the president do? That candidate says, if you elect me, I know this is not super likely, but I will provide you some insurance against that event. And so that fear, this is one way of understanding that why that fear ideology may work. And finally, there's a lot of work here on the trade-off between fit and simplicity, which I will skip, but I will tell you that the main gist of this is that if you go into an asymptotic environment where the number of observations is going to infinity, you can show very nicely the connection between what we're doing and Bayesian information criterion. And this tells you that the more observations you have, the more complex ideologies winning ideologies will be. So in a world that's very stable, you can sustain complex ideologies. In a world that's changing a lot, equilibrium ideologies will tend to be simple. And I think this is a good moment for me to stop and see if there are questions.
Thank you very much. This is excellent. We've had a lively discussion already. Perhaps we have time for one questions on the recording. Are there any questions?
So I have a question. But I'm one of the organizers. So if anybody else wants to ask, please go ahead.
Go ahead, Francesco.
So the other natural thing here is to think about pre-existing ideologies and in the public, right? And how that. So one thing would be to have. So this is a very abstract work, but to do that, you would probably need to sort of list what's available ex ante, what's the distribution of ideologies amongst the population, or something like that, and then try to work out what's going to happen. Have you had, I don't know, have you thought about this? Do you have any, something that you didn't write down, but intuitions, conjectures?
So I think it's very feasible. You can, so here our voter is born without anything. But you can let the voter come to this world with a prior. And then you will have that the candidates announce other models, and the voter will have a mixture between his own prior and these other models, and you can decide how skeptical the voter is of other models. And this takes us towards, I think, a very interesting extension, which is thinking dynamically. So thinking what happens when the voter in every election, and I think this is very realistic, we have our own ideology, like I have my own ideology, and over time I listen to candidates proposing new ideology, and I decide whether I want to update it or not. And I see what the data says, and I may change based on the basis on that. And so I think there's a lot of dynamic, interesting things that could potentially be done here.
Thank you very much. I think it's we hit the top of the hour, so let's do the official